All right. Welcome to Self-Affirmation, Your Guide to a Better Life. Um, Thanks for coming in. 9 a.m. on the last day of the conference. I appreciate it. This is going to be building Windows 8 and Windows Azure apps, and what you just saw is the demo app that we're going to be talking about. It's available as a web app at www.flatterist.com. That's flatter and then IST. And there include like the credits for if you were wondering who did that beautiful background music, it's something that I found that someone was good enough to Creative Commons license. If you go up to the webpage, you can get their link and thank them. So what a weird mood to start a talk in, right? We got this piano music and these nice sort of compliments, and then we go straight into geeky tech stuff. But it'll be fun. This is me. I'm Steve Marks. I'm a technical product manager at Microsoft working on Windows Azure. Just sort of actually moved into that role from being part of the engineering team that actually builds Windows Azure. So I am a Windows Azure expert. I am no more of a Windows 8 expert than most of you are. It's relatively new. I've been playing with it for maybe a couple more weeks than you have, but it's somewhat new to me. And so we're going to take the approach in this talk of, I'm going to make these assumptions. I'm going to assume that you guys are mostly web developers. You're comfortable building web apps. Is that true? How many people feel like they do web apps, they're good at that? Okay. I'm assuming, and this I know is true, or at least I hope so, is that you're new to building Windows 8 apps, because hopefully you didn't have it until just this week. And I assume you're fairly new to building Windows Azure apps. How many people feel like they're like Windows Azure pros, like they do a lot of Windows Azure, they know a lot about it? Okay, not that many people. How many people have actually used it, though, and have built something and tried it? Okay, that's most of the room. Okay, so we're gonna assume, I'm gonna kind of start out by going through a little bit of just sort of Windows Azure basics, what Windows Azure does, what you can use it for, with kind of a focus on the aspects of it you might use from an app that you were building in Windows 8. Then we're going to go and do sort of the flip side. We're going to look at Metro-style apps in Windows and what features of Metro-style apps you can take advantage of to communicate with some cloud backend and build something up. And then we're going to look at how do you combine those. What are the sort of common patterns? I've outlined, I think, 3 of them. That I think are sort of the major ways that people will put these two technologies together. And from that, we'll have sort of we'll basically all be on sort of the same page on how you might build a brand new Windows 8 Metro-style app that makes use of Windows Azure as, back-end cloud computing. So Windows Azure basics. Windows Azure is Microsoft's cloud platform. That means a lot of things to a lot of people, so I'm not going to even try to define what it is. I'm going to say it's a place where you can run your code in Microsoft data centers. You can also store your data there. You can do actually a lot of things there. It's designed from the ground up to be scalable, highly available, and to be agile, to make you as a developer able to build something really quickly, get it up and running really quickly, deploy to the cloud, etc. So as you go to build an app that you expect to run on a client device, you've heard in the keynote, as we pointed out, there are going to be more Windows 8 machines very soon after it ships than there are of any other sort of device. And so as you're targeting a client app, you're going to all of a sudden target a bunch of people all at the same time. And you're going to presumably, for a lot of these apps, have some sort of cloud component, some web services that you're calling, some data that you're storing in the cloud, something like that. So you need a platform that can scale up to all those users and kind of support you in doing that. And you also probably want a platform that can go global with you. And so that's another thing that Windows Azure does very well, is that we have data centers around the globe. We have traffic managers that can kind of route people to the closest data center. We've got ways to do data replication, do failover to another location. We've got a CDN that will sort of spread the content out around the globe and make it available from the closest data center that we have. We have 24 locations for the CDN. So this is the point of all this is the kind of cloud I think you want as you go launch a client app, really on any device, but today we'll be focusing on Windows 8 so that it can scale and kind of grow with you and with your user base. This is kind of all this. This is a screenshot of a page on WindowsAzure.com that just kind of shows the laundry list of features that are there. We're mostly going to talk about compute and storage, so those first two kind of on the left in this talk. But there is a lot more, and so I wanted to make sure I pointed this out. There's a caching service. There's a virtual network feature that lets you build sort of hybrid apps that run in your data center plus in the cloud. Access control for identity, a lot of things that we're barely going to touch on, if at all, because I really want to focus on just how do you wire up a Windows 8 app to talk to the cloud, and there it's mostly about running your code, which is the compute part, and managing your data, which is the storage part. Okay, so how does Windows Azure development work? You use any tools and any languages you want. I really do mean that. I like to pause and make a point about that. I'm going to show you some code, and I'm going to show you that code in Visual Studio and using C#. And that is probably the most common combination of technologies that people use to build Windows Azure apps, but it's by no means the only option. My blog runs in Windows Azure, and it's written in Ruby. I have a chat app at chat.smarks.com where you can talk to me if I happen to be logged into the app at that time, and that's running on Node.js, which is server-side JavaScript. I've got some other apps that are running Python. We've got a bunch of customers using Java and PHP. So I just want to make sure everybody understands that that's kind of, Windows Azure is a bit like Windows in that we control sort of the operating system and that sort of layer down. But up from there, it's up to you how you want to build your app, what frameworks you want to use, what languages. So the way the Windows Azure development works, for those of you who didn't raise your hand, who haven't tried this before, there's an SDK you download, and it lets you do all of your sort of development and testing locally. And then you go deploy to the cloud, where you will probably do your sort of end-to-end and stress testing in sort of a staging environment, and then you'll move it into production. We'll sort of briefly look at, I'll open up Visual Studio and show you a little bit of how that all works. Applications consist of roles. Roles is a term that we basically made up, although there was already such a term and it meant other things. But in the context of Windows Azure, roles are basically just components of your app. The way I like to describe it is if you're drawing for me the kind of boxes and arrows architecture diagram of your app, and you said, well, here's the front end, and then it calls back into a service over here, the boxes are roles. And I'll show you a picture on the next screen that will kind of make that even clearer. Each role runs on some set of VMs. So roles have instances, and instances are running VMs that are running that code. And different roles are scaled independently. So you could have a front end and a back end, and you could scale the front end out like crazy because lots of people are using the app. But the back end that just does some computation overnight to roll up the logs or whatever, you might keep that smaller. There are a number of storage options. We'll drill into each of these and talk a little bit about them. But SQL Azure is basically a database. Blobs are like really big files, and tables are the NoSQL kind of thing built in to Windows Azure. Okay, so let's talk about those roles and kind of what a typical architecture looks like in Windows Azure. So this is my app before I've put anything into it. So that dotted line represents a Windows Azure app. So I'm going to build something that's got a front end. So I'm going to use something called a web role. And the web role is basically a VM that's already got IIS running, and it's sort of ready to go. So you just sort of drop in a web app, and it runs it. As I said, you can scale each of these roles independently. So I might choose to have like 3 instances of my front-end web role for fault tolerance and sort of high availability. I always want to have at least 2. And then for scale, I might want to have more. Everything is behind a load balancer in Windows Azure. So incoming HTTP traffic to my web app is going to first hit a load balancer and then get round-robin routed to one of my virtual machines. So just something to keep in mind that's sort of always how it's built. And that's automatic and kind of on already, so you don't have to do anything. You just get load balancing. And now let's imagine I do have some sort of back end that's doing something. I'll build that in a worker role, and maybe the two will talk to each other. They might do that directly. They might use a queue to do that asynchronously in a more loosely coupled way. Or they might not talk to each other at all, because they may be actually performing different functions. The worker role might just crawl over some data or something like that. So a typical example, because sometimes this is a little bit vague until there's a concrete example of it, but if you think of, say, Flickr or some sort of, some photo sharing application, and you think of how that app works, there's a front end that you interact with. You kind of browse the web page, you search for photos, you upload photos through a front end, and then there's a bunch of back end work that happens to do to resize the photos into a bunch of different forms, to index them so that they can be found after you've uploaded them, so they can be found in search. Probably a bunch of analytics stuff and whatever. So there's always kind of this front end layer that's doing the UI, Then there's a back end that's doing sort of the background asynchronous work. Okay, let's shift over and talk about storage. I said we've got three options. The first one is SQL Azure. This is probably the easiest one for everyone to understand, even if you're brand new to this, because SQL Azure is a relational database. It's based on SQL Server, so it looks very similar to that. You go into a portal and click a button and you have a database. Change your connection string and that's about it. Then you can just use it. It is highly available by design, so it's built on replication, I think on 3 different servers, so all of your data is always kind of in a few different databases on a number of servers that are doing replication, and failover is automatic, so if something fails, it'll just start using one of the replicas and spin something else up. Okay, so the badly named Windows Azure tables, you could argue this is badly named because tables make you immediately think of a database, and Windows Azure tables is non-relational, so it's not a database it's not a relational database. And so it's not quite a key value store either, but it's more like that. It's a NoSQL sort of thing. It's really a collection of entities, you might call them rows, with a collection of properties on each, and you might call those columns. But each entity can actually have a different set of properties, so it doesn't have to be a grid, even though I've drawn a grid here. Like each row might actually have a different set of stuff. They don't all have to be filled out. It's designed for massive, massive scale out, and it's super inexpensive. So this is where you want to put your sort of billions of rows that you just need to sort of spread across an entire data center and access very quickly. So it's designed around sort of very, very sort of fast scale out, inexpensive, but it's missing a bunch of features that you might be used to from relational databases. There's no group by, there's no join, there's no sort. So everything is in the order of there's one key and everything's sort of in that order, right? And it's all accessible via OData, which is a REST-based, Atom-based protocol. And we're going to use that one, by the way. We're not using SQL Azure in the demo that I've sort of been playing with up on stage and that I'm going to show you. I'm not doing any SQL Azure at all, but I am doing Windows Azure tables. That's what keeps the list of all those complements that were appearing. This is really confusing for the people who are watching the video, by the way, because they didn't see the demo, but they'll figure it out soon enough. So all those complements were in a big table, and then all the audio was in blobs. So all the sounds that you heard were stored in blobs. And blobs are basically big files stored in the cloud. They can be very big, but I always get the numbers wrong. I think depending on the kind of blob you use, the maximum size for a blob might be 1 terabyte, I think, for a page blob. And for a whole account, you can have up to 100 terabytes before you have to go kind of get another account. So this is for sort of big scale-out stuff, but you can also store things like 5-second MP3s in there as well. It's a REST protocol, so like to get a blob, you do an HTTP GET, and to store a blob, you do an HTTP PUT. So it's a very simple protocol, but it has this authentication on it that's a little more complex. But there are nice libraries and a bunch of languages to help you out there. So there's the basic options for storage. Okay, so if you're new to Windows Azure, or even if you're not, one thing that I do want you to sort of leave with, I should have recorded a little thing. We should have made this one of the little compliments that goes up. But Windows Azure lets you manage applications, not virtual machines. I think that's if you just want to sort of, in a nugget, understand how Windows Azure is different from what's normally called infrastructure as a service kind of providers. One of the things that we're doing that not many people are doing, it's kind of going up to sort of the app level and not sort of raw virtual machines. And I think that's important, and we sort of feel that that's kind of a way to get you out of the out of dealing with a bunch of individual servers and into dealing with entire apps. So let's actually look at the developer experience for a second and show you how these things fit together. So we could actually build a new one, I suppose, if we want to. I do want to point out, if you're doing Windows Azure development on Windows 8, so if you got your new spiffy Windows 8 machine and you want to do Windows Azure development, you will need to install Visual Studio 2010 of some sort. The SDK for Windows Azure does not support Dev 11. And beyond that, there are a couple other gotchas to sort of getting stuff installed and started up, including an environment variable you should really set when you kind of launch things. If you're doing the, sorry, that's only if you're doing the toolkit. There's a Windows Azure toolkit for Windows 8. Did you guys hear about that in the keynote? And we're gonna use a small piece of that here. But if you're doing that, you also for both, you sort of need this environment variable that will help find the right things. So there's a little gotcha about that. Read Wade Wegner's blog, and he'll tell you exactly what you need to do. So anyway, so this is basically how you're going to create, and you can actually go pretty far before you realize that you need that thing set. So be aware of that. So we're going to create a new Windows Azure project. I'm running this, by the way, on like a 3-year-old laptop. So blame any performance problems on my laptop. This is where you pick those roles. So remember, I said, everything consists of a number of roles. They're all sort of scaled independently. This is where you pick them. So you might say that you want a web role and a worker role, and do it like this. And these are basically just templates. You can put something else in here, but these are handy templates for doing like MVC. And I don't know. Let's do the internet application. Well, this dialog doesn't work very well at this resolution. The keyboard works fine. And so this is going to create basically 3 projects for me. One that's sort of a Windows Azure project overall. That's where I'll like package things up and deploy them and stuff like that. And then it's also going to create one project for my web role and one project for my worker role. Those look like this, if it's done. So this is the overall sort of Windows Azure app project. This is a regular MVC application. The template actually does a couple nice things. It brings in some references that you might want, but you could just start with the regular MVC app. I think did Scott actually demo? I think he did demo in the keynote, just taking an existing app and sort of doing right-click and sort of make this a Windows Azure app. And what that would do is it would go from just having this to having this plus this. It would add this in for you. So you can go that way too. And then down here is a worker role. And worker roles are really simple. You basically override a run method and do something forever. And we don't care what it is you do. And so it's basically just like writing a C++ app with a main function. We just call you and you just go off and do whatever you want. And the web app is a standard web app, so here's some ASP.NET MVC stuff. I'm going to press F5 and we're going to wait for the extremely slow hard drive on my old machine to build everything. But this is going to actually sort of deploy my Windows Azure app, but to my local machine. And so it's going to bring up an emulated environment that just does all the functionality that the cloud has, but instead of running a bunch of virtual machines spread throughout a data center, it's going to run some number of processes on my local machine. And so that way I can do sort of full debugging while running locally. Okay, I didn't know it was going to be this slow to do. Normally this takes 5 seconds or so on my laptop. Well, it's kind of scary how slow that is. Oh, it just jumped. We'll see. If it doesn't work, you're not going to be missing much, because all it does is it's going to bring up the normal MVC page. The reason I wanted to do sort of the F5 here is because I want to make sure that people understand that you do this sort of development and functional testing locally, and you only need to deploy to the cloud when you're ready to do your integration testing or your stress or sort of things like that. Okay, I don't want to wait for it. We'll skip it. Okay, let's move on to the brand new fun stuff. Okay, so Metro-style app features. So by now everybody's kind of, you guys may by this point know more about building Metro-style apps than I do. But Metro-style apps are the new application model that's introduced in Windows 8. And it's about either building with HTML and JavaScript or with XAML and C#, and putting together apps in sort of this new way that sort of give a sort of full screen kind of experience, kind of take over the screen like that. So I've been tackling, so there are a few ways you can look at Metro-style apps, and it depends kind of what your background is and where you're coming from. I'm coming from being primarily a web developer for at least my recent work history. So I immediately saw HTML and JavaScript as an awesome opportunity for me to take what skills I did have in sort of web development and translate them into client app development. And I think that's kind of cool. And so there I started looking at, okay, how am I going to build a typical kind of client-server thing like I would in a browser where the sort of web page would be the client and my cloud application would be the server. And I started looking at what are the networking options. So how can I do that communication between the client and the server? And there are actually a few different ways you can do this in Windows 8 and Metro-style apps. One thing you can do is use XML HTTP request, better known as the thing that does AJAX. And so everyone who's built a web app in the past 5 years or so has probably used this already and understands that. And so that's a way to make HTTP requests to any server. The difference kind of between doing typical web development here is that this is a trusted app on the client, and therefore it doesn't have any sort of same origin policy restrictions. So you can actually make cross-domain calls. In a sense, there's no cross-domain because you're not on a domain. And so you can make calls to any server you want. So that's how you can do basic HTTP requests. There's also WebSockets, which is the new HTML5e way to do something akin to raw sort of TCP sockets, but with a layer on top that allows you to sort of establish those connections through the HTTP protocol and then do sort of two-way, sort of very fast, low latency kind of communication between them. So it's not request response, it's anybody can sort of send either direction. So that's supported, and so if you've been doing HTML5 development in the browser, not with IE yet, IE 10 will have WebSockets, IE 9 doesn't. But if you've been doing that already, WebSockets are kind of emerging as a standard way that web apps communicate with servers. And then you can also just drop down to raw TCP or UDP. So you can actually just drop down and open sockets and do communication. So which you can't do in a typical web app. So from my point of view, coming from sort of web development, that's quite a new capability. For people who are doing typical client apps already, they probably expect this, that they can open a connection and just do communication. So those are really the three options that I see that you have. I've been focusing on using AJAX because that's kind of what I'm familiar with. And this is what that looks like. So if you're doing a web request, you're going to do WinJS, which is sort of the JavaScript namespace in Windows 8 apps that has all this functionality under it. And then you're going to call XHR, XML HTTP request, and pass in some parameters. This is sort of the simplest possible form of that. It defaults to doing an HTTP GET. I've just put in a URL. So I'm using, that's flatterist.com is where I have this web app running, and it has an API. One of those methods is get random complement, and it returns some JSON. So that's why you see json.parse the response and pull out the text from it. So this is sort of a basic little function that will make a remote call, and then once the result comes back, have you guys gotten this, like you've seen this .then stuff before? How many people have seen it, like at least this week or whatever? Yeah, this is the promise way of doing, they're called promises. They do this sort of async thing. And so the .then is actually going to be invoked when this completes. And so this is not a blocking call. This will go, and it'll later execute that code. So don't be confused if you write things in sort of a linear order. You might be a bit surprised by that. So I thought maybe we can flip over and just take a look at that in sort of real code. By the way, it did eventually, while I was talking, bring up the MVC app. We may as well take a quick look at this UI. So this is not just Visual Studio launching the development environment, development web server and running this thing. This is actually Windows Azure's compute emulator. Okay, and that's not going to open quickly either. All right, we don't need it. Okay. So let me kill that thing, and we'll pull up this app. So this is actually the code that's running in Windows Azure. Here we go. Behind this stuff. So when I call get random complement, this is the code that I'm running. So let's look at the client side so that we can see. It's just what I showed you, but I just want to. So this is sort of a slightly more complicated version of that code that we just saw, but this is calling in the basic form. It's sort of calling get random complement, and then this is that XML HTTP request, and it's doing then, and when the result comes back, it's doing JSON to parse it. Okay, so this stuff is there's a little more complexity here, which we'll see in a second what that's all about. But that's the call, and here's what it's calling on the server. So this is sort of, I think, the most basic way that you're going to build, Windows 8 app that talks to Windows Azure is you're going to build something like this. You might use WCF to do this, to build a web API. That's a common way to do it. Here I'm using MVC, ASP.NET MVC3, which has a nice way to just return JSON from a method. And so this is getting called, this stuff at the top is really just making sure nothing gets cached, because I want a new complement every time you call. But this is code that's actually interacting with Windows Azure tables. So we sort of get, this is what it looks like. We're using link against tables, and so we're looking up a table called complements. We're looking by key. We're looking for everything that has an empty partition key. Partition key is the way you kind of define how things are spread out across servers. And here I've put everything on one server because there are only like 100 things. And until you have millions and millions, you probably don't care about that. And I'm filtering for ones that are approved, because the actual web app has a way that you can submit your own complements, and I don't want those to show up until I've screened them and made sure they're okay. So this little query here is actually talking to Windows Azure tables via that OData API, and it's bringing back a full list of these complement objects. And then here, I'm just picking one at random, and finally, I'm returning it, which actually calls this method, which creates a new sort of JSON thing that has some text, it has the audio for the thing, and it has an ID and whatever, right? But basically, the ones we're data binding with and whatever are these two. So that's it. So it's basically just returning JSON. And so that's how it's coming back to the client. Did that make sense to everybody? Okay. So let's look at data binding. So there's actually some built-in data binding stuff in that WinJS namespace, the WinJS UI namespace, and WinJS binding. So you do these HTML compliant, so HTML5, I guess, introduced the sort of data dash sort of namespace for putting attributes in there that aren't part of sort of the rendering, but are ways for you to attach data to an element. So that's what's being used when you're building a Windows 8 Metro style app with JavaScript and HTML. You're using those data attributes to define kind of what the templates are and how the data binding works. And this is basically what it looks like. So I have sort of an empty div, that's the messages div, and that's where I'm going to put all this stuff once I got it, and then I have a template. And the template see the data dash thing, so it has data dash win control, which says that I am a data binding template. And then each of the elements in there has some information about how the data binding works. So they're both just replacing the inner text of that element with the title or the body. So when you use it, it looks like the stuff down there. That first one, that winjs.ui.processAll, that's usually the thing you do up front to just kind of load all the controls. So that is the part that sort of combs through HTML and generates controls for all these things. And then when it's time to do data binding, you'll call getControl, and you'll give it, you'll grab the element that you want to get. So in this case, the template. So winjs.ui.getControl for that template is going to return me a binding template control. And then I'm going to call render on that and pass in some JavaScript object that has those attributes on it. So it has a title and it has a body. Those will get bound to the H1 and to the P, the paragraph tag. And then we're doing the promise thing again. So the .then gets called after the binding has completed. So that can do it asynchronously, and then come back and call that function. And the function gets an element that has been newly constructed. So in that code, that E in the function is an HTML element that has been constructed that has all the things filled out. And now I'm just appending it to the messages list. So that's how data binding works. It's actually, it's pretty nice. I've been comparing it, in my mind, coming from sort of the web development world, I've been comparing it to sort of a little bit like Knockout.js. If people used Knockout as a library for data binding, it uses a sort of similar way to kind of define how the binding works. It's sort of a combination between that and these other templates, like jQuery template and things like that, where you sort of grab a template thing and you say, okay, apply these settings. But the way that you define the data binding is a little more like Knockout. So anyway, that's how I've been sort of seeing it. But anyway, it's very easy to do. It's actually pretty straightforward. And so we can actually see that in code 2. I think actually a simpler form of that is in this one. So the code that I was sort of building up before the session actually started has some really simple data binding in there. Let me make this a little bit bigger. And actually, let's look at the HTML first. So here's the template. So this template is, so you see the same thing, data win control, winjs.binding.template, that says this is a template control. And then the binding, again, just taking inner text into sort of a header tag. But then the audio one is actually maybe a little bit surprising, as an example, where I'm showing here, you can actually take other sort of attributes or other settings on these things and set them. And so here I'm setting the source attribute, the src attribute on a source element and mapping it to this URL that I have for the MP3. And so here's where I'm actually calling it. So I'm getting the control. I'm calling render. I'm passing in some data. And then in the then function that I'm passing in here, I will get an element, and I will sort of do the append child here. So I clear it first. You know what? I should do that here. Oops. Does anybody know why I made that change? You know why that's probably a good idea to do it this way instead? I did that because the stuff that's running in the then, it's a promise, right? And it's asynchronous. So I'm sometime later running code that actually appends this to the thing. But before that, I was clearing it. And so in theory, if for some reason this took a long time, now all it's doing is some very simple data binding, but you can imagine it's possible that that's running sometime later, and now I've sort of blanked the thing, and then we're waiting before we fill it in. And it's probably better to do it this way, where sort of when we're ready, we clear the existing content and put it in. Very minor thing, but it's the sort of thing that I try to get in good habits around when I'm doing asynchronous code, because it's the thing that you can sort of forget about, that these things are actually happening at different times, and it's always possible for you to get interrupted by something else that takes a long time before this actually returns. So in the case of data binding, probably not a big deal, but in the case of making an HTTP request, this is absolutely something you should pay attention to, because there the latency of kind of getting the response back might be significant. So the data that I'm passing in is that text and audio blob, which is filling the thing in. I suppose especially for the people watching the video who did not see the 20 minutes leading up to the talk where we sort of played with this thing, we can hit F5 and actually, you know what? If I'm not too slow, let's set a breakpoint there so we can actually see what's coming back from the server, how we parse that, and then what's going to get passed in as we do our data binding. Okay, so this means we returned from our HTTP request already. So we called get random complement. We got something back, and what we got back, that's probably very hard to read, but it's a string version of some JSON that came back that has text and has a audio base URL. So if we step through one little bit, now we did JSON.parse, which means now we actually have an object that has some text and has an audio URL, and that's what's going to get passed into here. So we're passing in the text, and we're passing in the URL with sort of a suffix appended to it. And so, right, so if we run that, that's what happens. We get these things every 30 seconds or so that bring these up. And so, make that slightly quieter. But I want another one to come up because I like them. So this is, now I'm afraid to talk because I know at any moment my voice is going to come over saying something else. Yeah. That's very nice of you to say, me. So that's basically, you know, sort of making an HTTP request, doing data binding to sort of put that into some UI, and as you'll notice from the audio thing, it doesn't have to just be, you're not just data binding text to sort of text elements. You can actually do all sorts of data binding and data bind to things like the opacity of an element or things like that. And so it's a lot sort of richer than you might think at first glance. Okay. Notifications. Notifications are probably the newest thing. If you're coming again from my frame of mind, which is I came as a web developer looking at how can I apply my skills to Windows 8 client development, notifications are the thing that just didn't exist in my old world. Right? So notifications are new to that. They're not new if you were coming from another angle that people are coming from, which is building like phone applications on Windows Phone or on iOS or on Android. All these platforms have some form of push notifications from a way for the server to kind of push things down to your phone. And Windows 8 actually introduces this, I think, probably for the first time for sort of a client operating system. Because Windows 8 is for, you know, mobile-ish things like slates, et cetera, but it's also for laptops with keyboards, and, you know, it's a full-blown kind of client OS. So it's probably the first time this capability has been introduced for that kind of an operating system. It's pretty cool because it means that you now have a channel where you can send messages down to the client without the app even having to be open. Like nothing has to be listening for these things. You just have to sort of have declared that you want these notifications. So we'll see how that looks, but it's a little bit of a dance between the client and the server to get these notifications started, and then you can send things whenever you want. There are a few kinds of these. There are these tiles, there are badges, there are toasts, so that the tile, you know, you can change actually like the UI that appears on that on the home screen that has those tiles there. Toast is the one that I actually have a demo for that we're going to talk about. But if you want to learn more about this, you have to go back in time to yesterday to watch a talk. But fortunately, these are all online. If you're watching it online now, it's already there. If you're here in the room, just wait. Probably later today, it'll be online. You can go back and check it out. But there was a talk called Delivering Notifications with the Windows Push Notification Service and Windows Azure. It's a bit of a mouthful. It was given by Nick and Darren, who work on sort of Windows Azure and Windows Client, respectively. But they went through all the various options that you have for building this in gory detail. So remember I said there's this little dance that happens between the client and the server to get notifications started? This is the client piece of that dance. So if you thought that the title of that talk was a mouthful, just wait till you call windows.networking.pushNotificationChannelManager.create push notification channel for application async. That one's a tough one. But so you do call this method, which is a promise like everything else, so then you do a .then, which gets called once it's returned. So asynchronously later, you'll call the method from that you pass into .then, and you'll get a channel. And the channel is a URI that represents, I mean, it'll look like https://something.notify.windows. It's basically a URL that goes to the notification service and represents this running instance of this app. Or I shouldn't have said running, because it doesn't actually have to be running. It's this instance of this app, on this device. And so that URL is your address to send things to this app. And so you get back this channel object, and it has a .uri on it that gives you that URL. And what I'm doing here is I'm doing an XML HTTP request to send this up to my server. So I'm sending to, again, I have an API method called register channel URI, and I do an HTTP post to that, and I make it look like form data. So I pass in an ID and a URI. Here I've just hard-coded user1, but obviously here you'd have something that actually, well, there are actually two things you might do there for sort of for identification. But the important thing is that you sort of let the server know what the URI is, and then the server uses that URI to actually send the messages. Okay? And you typically do this in the startup of your app. So you actually do this in initialization of your app, which means every time people launch your app, you're doing this. And that's the way you should do it. Because channel URIs eventually expire, and so it's a good idea to just refresh. And sometimes you'll just get back the same one again, and no harm done. You'll just sort of save it again to the server. But sometimes you'll get a new one. And so it's important to keep refreshing these. Don't just do it once when people say, yes, I want notifications. Like, do this every time the app starts up so that you keep that fresh. OK, so let's come back to that ID, actually. Let's talk about that a little bit. So identity is something I will sort of point you to another talk if you want to learn more about identity. But identity is interesting here because there are a few models of how you might use push notifications. One is you might just do notifications to everyone who has the app installed, right? And so you might send these things out to everybody. Another one is that you might send these to specific users. So there might be some functionality in the app where I can send a message to someone. Or there might be notifications that are just per user, like you have new email, right? That's specifically for you, a specific user. So there are varying degrees of kind of what you need to know about the user to send these notifications. Do you need to actually know who they are? Or do you just need to know, well, this is a user of the app? And so if you need to know who they are, you need to use one of the available options you have for doing like live ID authentication or using access control services. You saw a demo in the keynote, the day 2 keynote. John Shuchuk was up on stage and he showed Margie's Travel, I think it was called. And he showed sort of some UI for logging in. And that was using the access control service, which was part of Windows Azure. You might use that to log people in, something like that. And then that might be sort of the unique ID you use when you save things. If you're sending notifications to just like everyone who's logged in, all you really need to do here is you need to have some ID that every time you save this channel URI, you save it with the same ID. Because remember I said that this is going to happen on startup every time. You don't want a long list of a bunch of URIs that are actually the same person. So you just need something that every time I launch the app, it's going to be the same. Here, I've assumed I'm the only user of this app because I am, and so I've just put in user 1. But something you might do here is choose a random number and just sort of save it locally or persist it in that in the sort of credentials storage that roams with the user. And that way, every time you run this, you're just refreshing that user's URI instead of sort of appending to a list. I hope that made sense. But if you go see Nick and Darren's talk, they may talk about that too. Okay, so this code is actually doing two things, right? It's getting the URI, which is sort of just an operation of talking to the runtime, and then it's sending it up to my server. Once I have that URI, I need to write code that actually pushes the notification out. This is what it looks like if you use the Windows Azure Toolkit for Windows 8, which is just released this week on Wednesday, I think. It does a bunch of things, but one of the things that it does is it has a library for sending push notifications. And so the things I haven't told you about are client ID and client server. I'll let you go play with that. That's the way you do the authorization and authentication as the sender of the message. That's how you say that you actually own this app and you're allowed to send notifications to these channels. So that's stuff that's basically hard-coded for your app. So you'll get that through the process you do when you sign up and start creating your app. And you'll just kind of plug those in. Then this new toast notification, the rest of this stuff, after kind of the auth stuff, is actually the content of, so the type is, I'm sending a toast message. It's got only one piece of text. So there are different formats. You can send images with text and things like that. It's normal priority, and I'm passing in some text to it. And then finally, when I call .send, that's where I use that channel URI. So that's what that looks like. And then in my example, I was doing this from a console app. I'll run that console app in a second, and then you'll be able to see the status code, which will tell us if it actually worked or not. Okay, so that code is in an app that I've got running on this machine, or well, rather that I have on this machine, compiled as a console app. So let's run this. And then I'm going to show you, well, we can actually step through it. We'll set a breakpoint and we'll sort of step through what happens. So this is basically a similar version of, yeah, it's doing the same thing. So this is a similar version of the app that we had before, except this one you manually refresh by clicking a button instead of doing it. But so this is the one that I built before, not sort of during the 15 minutes before the talk. And it's got a little more complex code. So it actually has some code in here. Let's do that full screen. So it has this, remember the super long push notification create blah blah async? It has that code. So you saw that already. This is exactly, I think, the code that we looked at that just sends the channel URI to the server. But it also has something different here. And so what this does, one of the things that you can do when you send a push notification is there's a launch. The actual body of that push notification is XML. So you can look at it if you go run these things. You can actually just look at the XML going by. It's quite readable, and it has an attribute called launch. Launch equals and then a string, and that ends up in here in e.detail.argument. So e is is basically the like event args that sort of get passed into this event. So when the thing is activated, e.detail.arguments has whatever text came in through that launch thing. And so that's a way that you can, through a push notification, actually when someone clicks the push notification and launches the app, you can kind of pass parameters in. And so what I've done, let's run it and just see. Oh, we actually have to do this. I need to find a complement to send to us. So let's find one. How about this one? WOIU. So I'm going to say push user1, because remember everything was user1, WOIU. And if the network likes us, you'll see this. So a little pop-up down here that has some text in it. And when I click it, it should come over here. Oh, come on. No? Well, good. I wanted to step through it anyway and see what was going on. Let's do it here. So let me do that again. Well, we can certainly. All right, you guys win, because that was the one that was supposed to come up, right? So, okay, wait. But then I'm not going to be able to set my breakpoint, I think. But now we've launched sort of another version of this app. I actually really thought I could do this, that I could have this running and go. Okay, so this is the first one, which actually we don't want, because that's going to have empty arguments. I love this app. Let's see if we can get it to do it here. Okay, there we go. So, so now we got called here, and we do have an arguments. Again, probably too small for a lot of you to read, but it does say the arguments is that string WOIU, which is just the key within my table for that stuff. So if we go here and sort of step through, we'll see that we do have an ID, and therefore we use a slightly different URL, which gets a specific complement based on that ID. And so this is the way that you can kind of, through a toast notification, launch people into the app to view the specific thing you were notifying them about. So if you're sending them, there's a new unread thing in the feed that you're reading, your RSS feed. This is a way you could sort of open the app directly to that and get it to work. So that was, in a nutshell, push notifications. But as I said, there was a whole talk about notifications and specifically using it with this new toolkit, which has a nice library for it. Otherwise, you're constructing XML. You're doing some OAuth and then constructing some XML yourself. So it's really nice to have a library. I do encourage, even if you're not looking to use the rest of what's in that toolkit, at least grab the library out of there that does these notifications, because it makes things a lot easier. Okay, so in the last few minutes of this, let's talk about some of the common patterns, and I'm really just going to leave these as jumping off points for you. I just want to kind of bring up a few ways you might combine technologies, and I'll point you to a couple talks that have happened already at the conference, and you can go online and check those out, but they dive a little deeper into a few aspects of these. So one of the common uses, and actually you could see this Flatterist app as an example of this, where you have a thin client and a thick server, I'm saying, which is, I don't think anyone actually uses that term, but it seems like that's sort of the opposite of the thin client. And so you've got some UI that's probably very rich and takes advantage of, the Windows 8 Metro style features, but doesn't have all the data. The data all lives on the server, and so you're sort of a browser for that thing. So you might think of a catalog for a store and a sort of viewer for that on your device. Or there's an example, actually, the weather app that I think there's the weather app in Windows 8 may actually use Windows Azure. Don't hold me to that. I don't actually know what it's doing. But I think it may use Windows Azure in the back, but it's the sort of thing where you might. So you might want to send notifications if there's a severe weather warning, or you might just want an app that can sort of periodically go and check the weather. You might also use push notifications to change that tile and things like that. And so you're generally keeping all the data and the business logic in the cloud on scalable farm of servers, and then you're keeping rich UI on the client. And you might have other interfaces too, just like I have www.flatterist.com, and I also have a Windows 8 app called Flatteris that accesses the same data. You might have different interfaces. So you might have phone apps, and you might have Windows clients, and you might have a web app, and anything else. And one of the advantages, actually, of having all this stuff in the cloud, having all the data and the business logic in the cloud, is that it's very easy to build lots of clients for the same thing. You see this a lot today with phones. I mean, you see the same app being built on several different platforms, and they all just rely on the same. They build the cloud part once, build all the web services the way that they need them, and then they just rebuild the UI for different devices. So to do this, you probably need some sort of storage, blobs or tables or SQL Azure. You probably want some kind of request-response communication, like XML HTTP request. But really, you could do this with WebSockets or something else if it was real-time sort of stuff. But it's most common to do it this way. And then you're probably using local data binding like we did. So this is actually, the app that we just sort of looked at through this talk is a fairly good example of this. And if you want to learn more about doing that, there's a talk that actually you're missing right now. Upstairs right now, there's a talk by Wade Wagner on using cloud storage for Windows apps. And so he dives into some of the patterns for accessing blobs and data that's in SQL Azure or tables, how to proxy that, et cetera, in his talk. So that's a good talk. I recommend that. I saw just this morning the final version of all the slides and stuff, and it looked very good. And there's another talk, which is also by Wade Wagner, that happened earlier in this week, which was building device and cloud apps. And so he talked about sort of the building many clients sort of thing, like how do you build something across Windows Phone and iOS and Android and Windows 8 and maybe a web app too. He didn't really talk about that part. And use the same cloud backend for all that. And so there are a bunch of toolkits you can use and a bunch of work that his team has done that's good. So check that one out too. Okay, so there's another pattern which I'll call real-time interaction. There are probably lots of things you might call this, but this is sort of a collaborative app of some sort. And a good example, I think, is a social game. You guys saw Tankster. I saw a tweet that said Tankster is the new Northwind, because we keep using it in different demos. But Tankster is an HTML5 app, but it's also a phone app. It runs on an iPad also. It's sort of many clients for the same app. They're all talking to the server, and you saw in the keynote them doing WebSockets to do chat back and forth and sort of real time, and also to play the game and sort of do all that stuff in real time. So that's a good pattern. I think that's a very good pattern for running things in the cloud. And there was a talk specifically about Tankster and how that was built. And that was yesterday. And it was called Building Social Games for Windows 8 with Windows Azure. And so check that one out. There's another. These apps typically need also some form of identity, because these apps are usually ones that you play with your friends. So you all log in with your Facebook account or your Live ID or Yahoo ID or something. And then there's sort of a social graph aspect to it, and there's playing with specific users. There's a leaderboard for which you need to actually know that it's the same guy from the other day to sort of keep the scores straight. And so there you actually usually do need some form of identity. To learn about identity and all the things you can do with that with Windows Azure, you always want to go to Vittorio Bertocci, who is Captain Identity, as I like to call him. Commandant Identity, actually, we promoted him. And he did a talk called Identity and Access Management for Windows Azure Apps. And he covers all the options that you've got for using access control and things like that. So go to that to sort of, or watch that online to learn about the identity piece, and then watch Nate Totten was the one who did the social games thing. He built that app, actually. And Grant Skinner built all sort of the UI and whatever, but he drove sort of that back-end stuff and knows a lot about that. So his talk for sort of social games. And the last one that I just want to mention before we wrap up is some sort of subscription syndication kind of thing. So think of pub-sub kind of things where you have a client app that's subscribed to something, say a set of RSS feeds, and then something running on the server continuously looking for updates or being pinged when something changes, that then sends notifications down to the client. And so here you need a way for the client to subscribe for these things, so you typically build some sort of web service that where you send a channel URI and some other information about like what this user wants to subscribe to. And then you send notifications down from the cloud. And so this is the talk that I mentioned before, delivering notifications with the Windows Azure, with the Windows Push Notification Service and Windows Azure. The toolkit that they talked about there and that we published, the Windows Azure Toolkit for Windows 8, is a good way to set that all up and get it working. And it's got a full-blown example of how to do that. And that's it. So these are those sessions, again, if you want to jot them down, or when you're looking at this later online, you can see. And that's my contact info in the corner. If you just remember Smarks, that's good enough, because you'll find my blog and my Twitter account, my email address, kind of all there. And that's about it for our time. So I will stick around and kind of hang out here, but we got to let the next guy get set up, so we can do some quick kind of Q&A in the front if you guys want. All right, thanks.